Hello everyone, welcome back to my channel Learn Math with me. Today in this video I am going to explain exercise 5.2 of continuity and differentiability. So before watching this video, please like, share and subscribe my channel, and don't forget to hit the bell button given below to get the latest updates of my video. So before watching this video, please make sure that you have watched part 1 video of exercise 5.2. Now fifth question, sine of ax plus b over cos of cx plus d. See, this is in the form of u by v. So as we know, derivative of u by v is vu dash minus uv dash over v square. Here u is sine of ax plus b, right? V is cos of cx plus d. Now we need u dash and v dash, right? So let's find u dash first. For that we have to differentiate u with respect to x, right? So derivative of u is sine of ax plus b, right? So derivative of sine x is, think this as x, forget this, okay? Derivative of sine x is cos x. In the place of x we have ax plus b. Now we have to find the derivative of angle. So derivative of ax plus b, cos ax plus b as it is, and derivative of ax plus b. Here d by dx of ax, a is constant, d by dx of x is 1, a into 1, plus derivative of b is 0, constant. So cos ax plus b as it is into a into 1 is a plus 0 a. So multiply this, a into cos of ax plus b. Now we got u dash. Now let's find v dash. For that we have to differentiate v with respect to x. So what is v here? Cos of cx plus d. Forget this cx plus d, think this as x, okay? So differentiation of cos x is minus sin x. In the place of x we have cx plus d. Now we have to differentiate angle. So d by dx of cx plus d. Put minus sin of cx plus d as it is. Now derivative of cx, d by dx of cx, c constant, d by dx of x is 1. So c into 1 plus d by dx of d is 0. Now multiply cx, sine of cx plus d as it is, c into 1 is c plus 0. Now minus c sine of cx plus d. We got v dash. Now we have u, v, u dash and also v dash. Now substitute this in the formula. Derivative of u by v is vu dash minus uv dash over v square. Now what is v? V is cos cx plus d. U dash is a into cos of ax plus b minus u is sin of ax plus b. V dash minus c sin cx plus d over v square. V square is v is cos of cx plus d whole square. Now cos of cx plus d cos of ax plus b minus into minus is plus sin ax plus b and here c sin cx plus d over cos of cx plus d whole square. Now divide denominator separately to the numerator. Okay. A into cos cx plus d cos ax plus b over, we can split this, right? Cos cx plus d into cos cx plus d. So next plus sin ax plus b into c sin cx plus d. Here also split and write cos cx plus d cos cx plus d. See here, cos of cx plus d cos of cx plus d get cancelled, right? So remaining a into cos of ax plus b into 1. Nothing, into 1 is a into cos x, please, same, over cos of cx plus d. Here there is nothing to cancel, right? So write as it is. Now I have written this as it is. See, numerator a cos of ax plus b. Now denominator is 1 over cos of cx plus d. As we know, I'll write here, see, 1 over cos x is secant x. So 1 over cos of cx plus d is secant cx plus d. Okay. Then write c into sin ax plus b as it is, and as we know, sin x over cos x is tan x. So here see, sin of cx plus d over cos of cx plus d, these two I will write separately, over cos of cx plus d into 1 over cos cx plus d. Write this as it is, ax plus b secant cx plus d. This is also same, ax plus b. Now sin of cx plus d over cos of cx plus d is tan of cx plus d. 1 over cos of cx plus d is secant cx plus d, because I told you 1 over cos x is secant x, and sin x over cos x is tan x. Okay, so in the place of x we have cx plus d, so we wrote tan of cx plus d. So that's it, the fifth one. Let's move to the sixth question. Here's the sixth question. Let me write it as y is equals to sin of cos x square Now differentiate y with respect to x. D by dx of sine of cos x square. Now think this cos x square as x. So we know differentiation of sin x is cos x. Cos of x. In the place of x we have cos x square. Now we need to differentiate this angle. So d by dx of cos x square. In the next step, cos of cos x square, differentiation of cos x square. Think this x square as x. So differentiation of cos x is minus sin x. In the place of x we have x square. Now we have to differentiate this x square, this angle. Okay. So d by dx of x square. In the next step, cos of cos x square as it is minus sin x square. Then d by dx of x square. It is in the form of x power n. Derivative of x power n is nx n minus 1. So derivative of x square is 2x 2 minus 1, that is 2x. Okay, that's it. Rearrange this. Minus 2x sin x square cos of cos x square. That's it. The sixth one. Very simple, right? Now without late, next move to the third question. Secant of tan root x. Y is equals to secant of tan root x. Now differentiate y with respect to x. So d by dx of y is secant of tan root x. Now forget this, think tan root x as x. Okay, we know the differentiation of secant x. D by dx of secant x is secant x tan x. In the place of x we have tan root x, right? So secant x means tan root x, tan x means tan root x. Okay, now we need to differentiate this x now, that is d by dx of tan root x, right? Write this as it is, secant of tan root x, then tan of tan root x. Now forget this x, think this as x. Okay, differentiation of tan x is secant square x. Secant square x. In the place of x we have root x. Okay, now differentiate this angle, right? That is root x. Next step, write as it is, secant of tan root x, tan of tan root x, secant square root x. We know differentiation of root x is 1 over 2 root x. So derivative of root x is 1 over 2x. This is side work. Okay, write as it is. Okay, rearrange 1 over 2 root x, secant tan root x, tan of tan root x, secant square root x.